So, good day everyone. I'm Kylene M. Viterbo from Bachelor of Science Criminology on Education. So, today our topic is about the kurtosis. Our points to cover: definition of kurtosis. Second is types of kurtosis. Number 3 is negative and positive of kurtosis. Number 4, tricks to remember. And the last one is what kurtosis tells us. So, definition of kurtosis. What is kurtosis? Kurtosis is a statistical measure that defines how heavily the tails of a distribution differ from the tails of a normal distribution. In other words, kurtosis identifies whether the tails of a given distribution contain extreme values. In statistical measure that is used to describe distribution, whereas skewness and differentiates extreme values in one versus the other trail. Kurtosis measures extreme values in their tail. Distributions with large kurtosis exhibit tail data exceeding the tails of the normal distribution. Distributions with low kurtosis exhibit tail data are generally less extreme than the tails of the normal distributions. So, types of kurtosis. There are 3 types of kurtosis. The first one is the leptokurtic kurtosis. I will show you how it look like leptokurtic is. This is leptokurtic looks like. So, leptokurtic, more values in the distribution tails and more values close to the mean. The second is the mesokurtic. So, in terms of their length, mesokurtic is lower than leptokurtic. So, the third one is platykurtic. So, this is platykurtic means. So, mesokurtic distributions that are moderate in breadth and curves with a medium peak height. The definition of platykurtic: fewer values in the tails and fewer values close to the mean. So, the third is the negative and positive of kurtosis. So, remember always when tails of distributions are heavier or thicker, but the center of the distribution is thinner in comparison to normal distribution, that is positive kurtosis. So, this one is leptokurtic, the second one is mesokurtic, the third one is platykurtic. So, when the tails of the distribution are heavier or thicker, but the center of the distribution is thinner in comparison to normal distribution, that is positive. And also, when the tails of the distributions are lighter but the center of the distribution is thicker in comparison to normal distribution, that is negative.
Ano itong ginagawa ni nini mo? Okay na la?
So, the tricks to remember, always remember the LMP. So, the tricks to remember, always remember the LMP. They are in alphabetical order. Leptokurtic, mesokurtic, and platykurtic. So, what kurtosis tells us? In many data analysis like parametric test, there is a prerequisite condition of data set to be normally distributed with the calculation of kurtosis, and it also tells us the points of our data set, at what points most of the data is located. For the group data, we have example here. So, the formula is kurtosis equals to summation of frequency times to the fourth power of the difference from class mark and mean over the number of the data in the set times the fourth power of standard deviation. So, here, the mean is 40.27 and the standard deviation is 14.99. Constant. Okay, let's start. 19 minus 20.27, it gives us negative 21.27. Negative 21.27 times 4, it gives us 204,677.43. So, this 204,677.43 times the frequency, it gives us 1,023,387.5. The next example is 30 minus 40.27. It gives us negative 10.27. Negative 10.27 times 4, it gives us 11,124.53. So, times to the frequency, which is 7, gives us 77,871.71. For the next example, 41 minus 40.27, it gives us 0.73. Times 4, 0.28. 0.28 times to the frequency, which is 8, it gives us 2.24. The next example is 52 minus 40.27 gives us 11.73. Times 4 gives us 18,931.81. Times to the frequency, which is 6, gives us 113,590.86. Next is 63 minus 40.27. It gives us 22.73. Times 4. It gives us 266,930.22. Times to the frequency, which is 3. It gives us 800,790.66. Next is 74 minus 40.27. It gives us 33.73. Then times 4 gives us 1,294,390.64 times to the frequency times 1 gives us 1,294,390.64. So, the total of this frequency is 30. The total of class mark is 279.
Pause na, pause na.
The total of class mark minus mean is equals to 37.83. So, here, class mark minus mean raised to the power of 4 is equals to 1,796,054.91. For the frequency times class mark minus mean raised to the power of 4 is equals to 3,310,033.26. So, kurtosis equals to summation of frequency times to the fourth power of the difference from class mark and the mean over the number of the data in the set times the fourth power of the standard deviation. So, equals to 3,310,033.26 over the number of set, which is 30, times the standard deviation 14.99 raised to the power of 4. It gives us 3,310,033.26 over 30 number of set, and 14.99 times 4, it gives us 50,490.13. So, proceed, equals to 310,033.26 times the 30 times 50,490.30 gives us 1,514,703.90. So, equals to kurtosis equals 2.9. 2.9 is equivalent to less than 3. It means Kati Kurti.
Okay.